Hello, third grade teachers. Today, we are going to take a look at Unit 4, Place Value, Addition and Subtraction up to 10,000. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies. Chapter 1, AKS and IOAs. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or the IOAs, for Unit 4. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. Later on in Chapter 2, we will take a look at how the AKS and IOAs in this unit are paced out in detail. Unit 4 has 3 AKS. On these next 2 slides, we're going to take a look at the AKS and the IOAs that support this unit. Just as a reminder, at the end of each AKS and at the end of each IOA, in parentheses, you will see that we have the state coding at the end, so that if you are looking up resources on the Georgia DOE website, you are able to find that IOA that is related to our GCPS IOA. Unit 4 begins with place value. We will now be diving into place value up to 10,000 and building off of what was taught at the beginning of the school year with place value up to 1,000. We also will be introducing rounding. In AKS 1, IOAs 1A, 1B, and 1C, students will be able to read and write multi-digit whole numbers, as well as compose and decompose numbers in various ways. This includes using base 10 numerals, expanded form, base 10 language, and exploring numbers being represented in multiple ways. Students will also use place value reasoning to compare numbers up to 10,000 and using the greater than, less than, and equal to symbols to record the results of those comparisons. Finally, students will round numbers up to 1,000 to the nearest 10 or 100 using that place value understanding. You will also see an extension IOA listed with this group of IOAs. The new extension IOAs are there to support the differentiated needs for students. As you can see, the word extension is listed in bold and in parentheses to notify you that this IOA is specific to Gwinnett County. Please note, you will not find resources from the state for these IOAs, and you will also not find these IOAs paced on the pacing guides. Next, the unit will shift to applying this place value understanding to AKS 2. This unit will revisit IOA 2A and introduce IOA 2B, where students will add and subtract multi-digit numbers within 10,000. Students will solve problems using part-whole thinking and generalized procedures. They will continue working with all problem types, which include start unknown, change unknown, and result unknown. Students will use a variety of models and representations when extending their understanding of part-whole reasoning strategies. We will continue to incorporate IOA 2A to support students in reaching fluency with adding and subtracting within 1,000. AKS 5 and 5A are ones that will continue to appear in multiple units because they are not taught in isolation. IOA 5A is embedded with 2B with the focus of interpreting and reading tables. You will also see 3 extension IOAs with this AKS. Remember, the new extension IOAs are there to support the differentiated needs for students. These are indicated by the word extension at the end of each IOA and you will not find these resources on the State of Georgia website or listed out on the pacing guide. Chapter 2, Unit Pacing. Our pacing guide is closely aligned with the state pacing. With the first year of new standards, we want to ensure we are following the expectations from the state. The pacing guide is an example, intended to model how instruction of the AKS and IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. Now let's take a look at the pacing guide to see how the AKS and IOAs have been paced out over the course of Unit 4. In this portion of the pacing guide, you will see the name of the unit, the big ideas for the unit, and the suggested pacing. Unit 4 will focus on numerical reasoning, patterning and algebraic reasoning, and measuring and data reasoning. The suggested pacing for this unit is 5 weeks. In the next box, we will see the first AKS and IOAs that will appear in the unit. Unit 4 begins with AKS 1. This unit has been divided into 2 parts, a focus on place value and then a focus on adding and subtracting within 10,000. The left column of the pacing guide will list the progression through concrete, representational, and abstract strategies. The bullets also indicate the learning objectives for the day, as well as suggested manipulatives. The right column of the pacing guide shows the instructional resources that align to the intended learning objectives for each day of instruction. Some days, you will see instructional resources linked for the numeracy components of a traditional teacher-led lesson. On other days, you may notice a task-based lesson, which is your full numeracy block for that day, such as this one for IOA 1B. You will also see resources from the Georgia DOE website, along with lessons from Georgia Reveal, our newly adopted resource. As you can see, we begin Unit 4 with AKS 1 and IOAs 1A, 1B, and 1C. This is for a suggested 10 days. These IOAs are building off of where we left off in Unit 1 as we move to work with numbers up to 10,000. We begin with a few days of representing numbers within 10,000 and introducing the thousands place value to students. We will represent numbers using place value discs. That is a new tool that we will be using during this part of our unit due to the magnitude of the numbers we will be representing. Then, students will engage in an inquiry task-based learning lesson for students to begin IOA 1B to build and compare whole numbers. Students will be expected to compare whole numbers represented in standard form, expanded form, or even using base 10 language. Finally, students will learn to round whole numbers to the nearest 10 or to the nearest 100. It is important for students to round whole numbers for authentic purposes. Rounding strategies are valuable for estimating, justifying, and predicting the reasonableness of answers. We also include a lesson on computational estimation. This lesson is to help students see how rounding can support making estimates before adding or subtracting. It is a great way to lead us off into the second part of Unit 4. After working with place value and rounding, we move into AKS 2 with IOA 2B and 2A as our primary focus of working to add and subtract up to 10,000. This will be our primary focus. Remember, the left-hand column will guide your instruction with regards to learning targets, problem types, and the learning progression for these IOAs. We begin with addition strategies with two multi-digit numbers without regrouping, using place value disks and transition to representational strategies, all while using the expanded form equations. Considering the magnitude of these numbers being added or subtracted, drawing or using base 10 blocks will become cumbersome. So it is more effective to use and draw place value disks to represent the values of numbers. We'll take a look at how to use those in our instructional strategies video. Specific problem types have been listed in the left-hand column, and sample lesson plans each day will show an example of how that problem type can be modeled to students. As students begin regrouping, you will notice we follow the same instructional learning progression where we go back to concrete and modeling using place value disks. The structure is the same as for Unit 1. On the abstract days, you will see that we begin using a strategy called partial sums. Here, we included specific resources from Georgia Reveal to help support this instruction. You may also see that the standard algorithm for addition is included as a possible strategy for students. It is important to connect the expanded form to partial sums and then partial sums to the use of the standard algorithm. Also note that students do not have to be successful in using every addition strategy. We encourage, as does the state, for students to choose the strategy that is most efficient and effective for them. Then we transition to subtraction within 10,000, following the same progression as addition. We will begin subtracting two multi-digit numbers without regrouping using place value disks while including the expanded form equations. Next, we will subtract with regrouping, moving towards more abstract strategies. You will see we will decompose to subtract within 10,000, and we will also use an algorithm to subtract. The standard algorithm for subtraction is the most efficient strategy for students to use when subtracting multi-digit numbers. However, this strategy may not be the most efficient for all students. It's important to note that students do not have to master every strategy. As I've already said, the goal is for students to use the strategy that is most efficient for them. I really can't say that enough. IOAs 2B and 2A will be addressed later again in Unit 5. Chapter 3, Instructional Strategies. This portion of the video will highlight specific instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards, or ATS, for guidance on additional instructional strategies for each IOA. Hey there, third grade teachers. We're going to take a look at this problem for AKS 1, IOA 1A. This AKS and this IOA is a repeat from Unit 1. However, we are now working with numbers up to 10,000. You will notice in this video, we are going to talk about instructional strategies using our place value discs, which is a new tool for our students to be using. But it is very helpful to use this when working with numbers that are as large as the ones we work with now in 3rd grade. So based on that magnitude of the number, that's why we're going to take a look at these place value discs today to help us solve this problem. So I'm going to start out looking at this concretely of how we can represent this number in different ways. Okay, so before we get into looking at some of the different ways to represent this number that's given to us in this place value chart, let's first take a look at how we can represent numbers using the place value discs. Now, students are going to be very familiar with those base 10 blocks, but we may not have enough of those cubes to represent thousands for each student to really be able to represent those numbers. Plus, those cubes are really hard to draw when we get to representational. So we're going to take a look at how we can represent this number using our place value discs. All right, teachers, first things first, I am going to draw my own place value chart here. You can use a printed place value chart, that works too. Okay, but when I want to model this for students, I take a look and I notice that I have a 7 in my thousands place, an 8 in my hundreds place, 0 tens, and 2 ones. Okay, so that's going to help me not only to build my number, but also to represent my number. This place value chart also labels the ones period and the thousands period. Notice how it does show hundreds, thousands, and 10,000s. We don't go that high within 3rd grade. They'll move up towards those larger numbers in 4th grade, but it's always, okay to show students that there are other place values that extend above thousands. That's really okay to expose students to that. But we're going to be focusing with numbers that fall from thousands to ones, okay? So that's the numbers we're going to work with today. So let's build a place value chart. Again, if you would want to use one you already printed, that's okay. I'm going to do the best I can here to make this place value chart, but also have room for all the place value discs. Okay, so I'm going to go through and I have 4 place values that I'm working with. I have my thousands, I have hundreds, I have my tens, and I have my ones. Now remember, we have already worked with 3-digit numbers so far in 3rd grade. So students should be familiar with these 3 place values. This is the new place value that we are adding on for this unit. Okay, so now that I have my place value chart, and again, you would want to build this like I am under the document camera, or use magnetic place value disc and build this up on your board for students to see. Either would work, okay? So here I want to build a number and it needs to have 7 thousands. So I'm going to take my place value discs and I am going to represent my 7 thousands. Okay, now one thing to note for students that these are now circles, right? And they list the value inside. So I know each of these values, each of these circles has a value of 1,000. It's just another way to model the value of this number, okay? And one thing that I really like about the place value discs is that some of them do come in different colors, which might be visually helpful to support students who need to see those different things as you scaffold towards representational. Okay, so here I have 7 thousands. Let's double check. 1, 2, 3, 4, 5, 6, 7. Okay, so I've built my 7 thousands. Now I need 8 hundreds. So I'm going to build that next. Now again, I probably should have had my paper turned sideways, and that's okay. Making this work for under the document camera, right? Okay, so I have my thousands and I have my hundreds. I have 8 hundreds. Notice this time, these circles now have the value of 100 inside. So I see the difference of the values because I'm actually having to label these values, which could be very helpful for students whenever they are working with these place value discs. Okay, now notice I have 0 tens. Okay, so a lot of times we might say that a 0 is just a placeholder, but that's actually not true here. This 0 has a value. It tells us that we have no tens in our place value chart. Okay. When I represent this number this way, I have 0 tens. Okay. And I'm going to show you how that could change in just a moment. All right. And then I need to show my 2 ones. And these are just going to be circles with ones in them. Okay. Now I do want you to notice that unlike our place value blocks, these each are the same size. 1,000 circle is the same size as 100 circle, which is the same size as a 1 circle. But what's different here is that value inside of the circle. So that's what's so important for students to realize, because when they go to draw place value discs, you could maybe draw the thousands a little bit bigger, but you don't really have to, but you do need to draw it big enough to where you can write the number inside. Okay, so this is a way that I can represent the number 7,802. Remember, we don't say the word and when we read whole numbers. Okay, 7,802. Now, I can represent this same number in a different way. Okay, and this is where our base 10 language comes in. So I might say I have 7,000s, 800s. I could say 0 tens or just skip it and I have 2 ones. But let's think, is there a different way to represent this same number? Is there a way that I could represent so this number now has some tens? Yes, I actually can. And I need one of these hundreds to help me do that. So we know that 100 has the same value as 10 tens. So what we're going to do here, we're going to represent this number in a different way. Okay, so I'm going to take this 100. If I take it out of the number, though, that changes the value of the number, right? So what do I have to do? I need to exchange that 100 for 10 tens. And I really didn't make my place value big enough here. And I don't really love that I'm overlapping. 5, 6, 7, 8, 9, 10. Okay, so again, I'm not going to want to overlap those. I need to have a bigger place value chart, right? I should probably have this vertically made, but this now has the same exact value as when I had no tens and this 100 inside. Okay, so now the value of my number, I have 7,000s, but now I only have 700s, 10 tens, 2 ones. All right, so these place value discs are a really great way to help students to be able to do those exchanges and to help them learn how to represent the number differently and incorporating that base 10 language. Now remember, students will already have a background with base 10 language and standard form and expanded form because we've already done that work so far this year. We started that understanding in Unit 1. So this is building on that knowledge. So it's really going to help those students who need to see that again, and it's going to help reinforce those place value understandings. Okay, so that's how I can use my actual place value discs. Now, one thing we know is that we want to help work our students up to using representational strategies, right? Because we know students will not always have those place value discs to help them represent those numbers. So if I wanted to represent this number in different ways, there are a few other representational strategies and more to abstract strategies I can use. So again, I can draw my place value chart. Okay, I can have my thousands, my hundreds, my tens, and my ones. Okay. And now I'm going to draw each of these representations. So it could be very helpful to pair, and actually I would probably do it this way, right? To pair your concrete understanding with your representational understanding, right? I have 7,000s. So remember when we use our place value discs, we grabbed out 7 of our circles worth 1,000. So this time I need to draw 7,000s or 7 circles that are each worth 1,000. 1, 2, 3, 4, 5, 6, 7. Now remember, I don't want to just draw the circles. I now need to go back and write the values inside. So this is where we know our students need to be very careful with their neatness and their organization here, right? So I want to make sure that I've drawn my circle big enough that I can write the value inside. So my number has 7,000s, and I have drawn my 7,000s in my place value chart, and I can see how that relates over here to my place value discs. So I have 1, 2, 3, 4, 5, 6, 7 in that place value. All right, so now I have 800, so same thing. 1, 2, 3, 4, 5, 6, 7, 8. But this time, remember students, teachers, I have to write the correct value inside, and I am representing hundreds. So each of these circles or place value discs have a value of 100. Okay. Now, tens, remember, this isn't just a placeholder. It is telling me that I have 0 tens represented in my number. So there's nothing I need to draw. Okay, so that's very helpful here. Finally, I have 2 ones. In each of those, I'm just going to place a 1. Now, you could also go ahead and as you draw this number in your place value chart is write the value of each place value, which is really helpful for expanded form. So remember, I have 7,000s, so I could count by thousands: 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000. My hundreds, I have 800s, I have 0 tens, and I have 2 ones. Okay, so it is also very helpful. You can do this also when you work with just your, sorry about that, when you're working just with your place value discs. You can go ahead and write those values underneath or use a sticky note if you're using magnetic place value blocks on the board to show the values of each of those, which will help with expanded form. Okay, so now, just like we did when we were working just with our 3-digit numbers and working towards just understanding these first 3 place values, we can represent our numbers in multiple ways. Okay, I'm going to go ahead and move my manipulatives. Okay, give myself a little bit more room down here. So I know I have standard form. And the standard form of my number, another way to say that is using my base 10 numerals. Students might see either or in a question, right? Represent this number in the standard form, represent this number using base 10 numerals. They mean the same thing. So this is really helpful in my place value chart. I can see the standard form here, right? And I do have to make sure I write that 0 in to show that I have 0 tens. So I'm going to write my number 7,802. Okay. I also can talk about, and students will probably have this background from Unit 1, how I can use the values of the digit because this does look like expanded form, and I can add them all together in order to find my standard form of the number. So since we already have these values here, let's go ahead and write this number in expanded form. So remember, when we represent numbers using expanded form, we're using the value of each digit, okay? So with this problem specifically, there's actually more than one correct way. Actually, with all numbers, there's more than one correct way, okay? We always just tend to default to the standard expanded form that we would use for adding and subtracting also. So this expanded form could look like 7,000 plus 800 plus 0 plus 2. Now, when I'm working on adding and subtracting numbers, this is probably how I'm going to want to write my expanded form because it is showing that I have 0 tens for this number. So it's really helpful when I'm adding and subtracting to know that that place value is a 0. However, it is still correct if students write 7,000 plus 800 plus 2. Both ways are correct. Now, one can argue, we could go through and write this number out as 7,000 plus 700 plus 100 plus 2. That is still correct. It is still an expanded form of the number. However, we tend to default to writing out each place value of the number, or each value of the digit in our number, okay? Because that is helpful whenever we work with adding and subtracting. But it is really helpful for students to know they can be flexible with how they represent these numbers, because I could need to decompose this 800. It might help me to subtract if I decompose this 800 into 700 and 100, or to 400 and 400 and whatnot. And we'll see that more whenever we work with some of our adding and subtracting strategies, how we can decompose our numbers to be a more friendly number to work with. And that's the purpose of having this expanded form of understanding. All right, and last but not least, we know we can write numbers using our base 10 language. And we talked about this a little bit earlier in the video, right? So with base 10 language, I take the digit, right? Or the number of thousands that I have, and I'm gonna pair that with that place value. So I have 7,000s. I have 800s. I have 0 10s. I can write the 0 10s if I want to, but in this case, I'm not going to. So I'm just going to write 2 1s. Okay. So that is perfectly acceptable. But remember, I can represent this number in different ways. Remember how with our place value discs, I exchanged one of my hundreds for 10 10s. Okay. So if I do that, this would be my answer. I'll write this one in a different color. So if I did that, I could show 7,000s. I went down to 700s. Okay. And then that gave me 10 10s and 2 1s. I was thinking the ones place and I wrote a 1. Okay. So remember, both ways are correct. Okay, this is really important because students might have to look at a list of different representations and have to choose which one matches the value of this digit. Sorry, of this number, not just the digit. Which representations match the same value as this given number? So this is really helpful. You can incorporate these also later on into activating strategies. It's a great little warm up when you bring kids to small groups. So lots of different ways that you can keep encouraging this. After you start unit 4 with place value and representing numbers, you move into comparing numbers, which you will continue to compare numbers that are represented in multiple ways. So you might be comparing a number that is written in standard form with a number that is written in expanded form. So it's another way to keep building off of that understanding. It's another great thing that we're noticing with these new standards is how they really complement each other and how we can use the other parts. And that's why these IOAs have been clustered together. So this is how we will work with representing, reading, writing those multi-digit whole numbers up to 10,000. Third grade teachers, let's take a look at a problem for AKS 1, IOA 1C. This involves rounding to the nearest 10 or 100. So one thing I want all of us to remember is that we can always start with using some of our manipulatives to help us concretely teach rounding, right? You will find in the Analyzing the Standards ways to use the hundreds chart. You will see ways to use your base 10 blocks. So please refer to that document to help you see some of those concrete understandings, okay? I do want us to take a look today at how we can use rounding more representationally and using number lines. So that's our focus for this video today. We're going to use this problem. I love this problem because it really allows us to explore rounding both to the nearest 10 and to the nearest 100. And it really helps students to start really looking at how we can use rounding truly as estimation, how it can help us solve authentic problems. And we shouldn't just be rounding in isolation just to round. Okay, so let's take a look at this problem so you can see a way that you can model this with your students. There are 776 students at Lawrenceville Elementary School. The principal would like to purchase pencil boxes for each student. About how many pencil boxes should the principal buy? Okay, let's think about this. What do we know about this problem? Well, first of all, I know that there are 776 students at Lawrenceville, right? That's probably an approximate number. So if I have my Lawrenceville teachers looking at us, we've got that number from, it could be last year's enrollment, okay? So when I take a look at the question, it says about how many pencil boxes should the principal buy? I'm not necessarily adding anything here, not necessarily subtracting. I just need to know about how many should the principal buy, okay? So when we see this word about how many pencil boxes, that should tell me, hey, I need an estimate. This tells me the principal doesn't want to know exactly how many to buy. He needs an estimate, okay? And an estimate is an approximate number. And a lot of times this is helpful because we don't always need to know the absolute exact answer. Okay, so one thing we can use to help us find an estimate is we can use what we know about rounding. Okay, and we can round numbers to the nearest 10 or to the nearest 100. That's the only place we will focus with rounding in 3rd grade. So let's first take a look at how we will round to the nearest 10. Okay, let's start there. So let's use a number line. Okay, I'm going to draw my number line to help me figure out an estimate for my total 776 students rounded to the nearest 10. Now, when I do this, in this case, the 100 board may not help me in the sense that this number board only goes up to 100, right? So this might help when you're working with numbers less than 100. Okay, but it could help you if you need to see some things about the tens place, right? So remember, our number was 776. If I'm going to round this to the nearest 10, problem didn't tell me to round to the nearest 10, but I know I can. I'm thinking, if I'm rounding to the nearest 10 here, then that means I'm probably either rounding to the nearest 70, nearest 80. Now, how do I know that? Well, when I look back at this problem, I see that there are 7 tens in the number 776. So if I'm going to do an estimate here, I know this number is either going to round to the number of tens it already has, which would be 70 or 770, or the next 10. Okay, so that's where this number line is really helpful. So I have 770 as one of my benchmark numbers because I can either round this number to the 10 it currently has, right? To the 10, to that 7, which is 7 tens or 70, but I also want to include the value we have in the hundreds place because this value would be 770, or I want to go to the next 10, which would be 780. So that's where that 100 board could come into play when I'm looking for what 10 do I currently have, because it could round to that number, or it could round to the next 10, which would be 780. So again, this is a great number to use when rounding to the nearest 10 because you're also having to incorporate that other place value. That 7's just going to stay the same, okay? The 7 in the hundreds place. So that 700s for this problem, when I round to the nearest 10, is going to stay the same. It might not always, okay? Think about if that number was 790, just putting that out there, okay? So these are what we call benchmark numbers. This helps me when I'm rounding to the nearest 10 because I'm looking at the 10 I currently have or the next 10. There's also another important number we like to have to help us when we're rounding a number to the nearest 10, and that's the midpoint. Okay, it's considered another benchmark number. We just happen to call it the midpoint because it's halfway between my 2 benchmark numbers. And in this case, because I'm rounding to the nearest 10, I'm thinking halfway between 70 and 80 or halfway between 10, and that would be 5. So 775. So a lot of times students do have trouble trying to determine what this middle or midpoint number would be. And a great way to look at that is to, again, use that hundreds board, okay, if you need to. And remember, I have 70, I have 80, that 75 is going to be right there in between, okay? So it's another way to anchor that for your students, possibly in small group if you need to show them that too, or if you happen to have a hundreds chart as an anchor chart up in your room. So here's the number line I have set up to round this number to the nearest 10. Now, the number I'm rounding, remember, is 776. I use this number line so I can then place my number on the number line to see where is it closer to, okay? So if I'm thinking about 776, well, my midpoint was 775. The very next number on my number line, so let's approximate and say about right there, would be 776 because it is greater than 775, okay? You can also pull on what you've learned with comparing numbers here when you're teaching this IOA. Okay, so 776 is a little bit higher than that midpoint. So when we're rounding numbers to the nearest place value, we do use that midpoint to help us because it helps us to see, is our actual number closer to the next 10 or closer to the 10 we currently have? Okay, in this case, this 776, because it's on this side of my midpoint number, it is actually closer to 780. So if I was rounding 776 to the nearest 10, it would round to 780. But remember, what does that relate to in our problem? That means this rounds to 780 pencil boxes for the principal to buy. Okay? So, does that sound right? Does that sound reasonable? I mean, it does. It could, but I wonder what would happen if I estimated to the nearest 100, because remember, my problem doesn't tell me which place value that I have to round to, right? Because in authentic situations, we have to determine which place value makes the most sense to us. So let's take a look here. And what would it be if we did round to the nearest 100? What would that look like? Okay, so I'm going to draw another number line here. Okay, because that's the strategy I'm using to help me round. Again, I'm still rounding my number 776, but this time I'm rounding to the nearest 100. So I'm not thinking about the 7 in the tens place, I'm thinking about the 7 in the hundreds place. Okay, so this time there is no number in front of that 7 that I need to look for. I'm really only thinking about the value of the 7 or 700. So does this number round to the current number of hundreds I have, which is 700. And that's a great way to explain that to students because we don't want to say that we're rounding down. That's not really what's happening here. I'm rounding because I'm not going down the number of hundreds. I'm rounding to the same number of hundreds I already have. Okay, so I already have 700s. Am I starting with 700? Right? That is a good benchmark number because 600, that literally is going back a whole 100. And I'm either want to round to the 100 I already have or the next 100. So the next 100 would be 800. So here are our two benchmarks this time, 700 and 800. Okay. So now with my midpoint, okay, those are my benchmark numbers. Now I need to determine my midpoint before I can plot my actual value on the number line. My midpoint is halfway between 700 and 800. And some students might say 705. Well, why would they say that? Because we used 5 in the ones place here, okay? So we need to remind students that when you're thinking of 100, half of 100 is 50. Okay, so our benchmark number here, our midpoint would be 750. Okay, that's our halfway mark, halfway between 700 and 800. And again, the whole reason we use this number line here is to help us see what our number is closer to help us round. So now I'm going to plot my actual number. So I'm thinking about my number 776. Okay, and I noticed that 776 compared to 750. So again, see how comparing numbers helps us here. So I'm building on that IOA as I develop this IOA. So 750 is my midpoint. Well, I know 776 has 7 tens. That's 2 more tens than my midpoint number of 750. Okay. So again, I'm estimating here. I'm imagining that I have like 760, 770, 780, 790. So I'm going to estimate my 776 about right here. Okay. Probably actually might be a little bit more in the middle. But again, for my purposes here today, what matters most is where, according to the midpoint, is our actual value. Okay. Yeah, it might actually, because now that I think about it, it might actually be like right there, but that's okay. Okay. Again, I'm making, this is my estimate. This is helping me to see where it is on my number line. And I don't want students to think that they have to draw out all the pieces on their number line. They're making an estimate here, but thinking about those tens. So I noticed that 776 again is to the right of the midpoint. So now is it closer to 800 or is it closer to 700? Well, we can see the distances here, right? This distance is a lot larger than this distance. So my number 776, when rounded to the nearest 100, rounds to 800 pencil boxes. Because remember, that was our purpose for rounding today. I need to be able to tell that principal at Lawrenceville Elementary School, hey, how many pencil boxes should you buy? Okay, so when I take a look at this, well, both answers could be correct. And students are going to say, no, there has to be only one right answer. Remember, no, friends, sometimes in math, there are more than one correct answers. So sometimes we have to be on the lookout for those. And this is one of those situations, because in this case, I rounded to the nearest 10. This is the correct answer for rounding to the nearest 10. But this is an answer that's correct for rounding to the nearest 100. And remember, my problem didn't tell me which one to round to. So I need to sit here and think, which would be the most appropriate one? Well, guess what? Both could be the right answer. It's all in how students explain themselves, right? How do students explain which one is it? So this is where their explanation is really going to come into play. And it really will start with students saying those explanations out loud to you. So for example, a student might say that this way is correct, right? And they might say, well, I'm going to round to the nearest 10. That's the correct answer. About how many? Okay. I'm going to say that he should pick 780 pencil boxes. Should be the amount that, because about how many pencil boxes should the principal buy? Well, the principal should buy 780 pencil boxes, okay? Because when rounding to the nearest 10, okay, I chose 780 pencil boxes because when rounding to the nearest 10, there would only be 4 extra pencil boxes. Okay, it might be more cost effective. Now, why is that? How did I know there was only 4 extra pencil boxes? Well, I know that 776 is only 4 less than 780, right? So that would mean if I suggested to the principal to buy 780 pencil boxes, they would have 4 extra pencil boxes left over. This might be more cost effective. I might not want to waste anything. This could be especially useful when working with food, right? I might not want to have too much food left over because then what if that food spoils? And in this case, I would only have 4 extra. So in this case, yeah, I can round to the nearest 10 and get 780 because I'd only have 4 extra pencil boxes. It's more cost effective, okay? So what if a student said, no, I'd round to the nearest 100. So, about how many pencil boxes should the principal buy? Well, the principal should buy 800 pencil boxes. Okay. That's how many they should buy because if we round to the nearest 100, we would have, or the principal would have, 24 extra pencil boxes. Okay, this could be helpful. These could be for new students who move in. Doesn't that sound authentic? Doesn't that sound reasonable? Well, yeah. Think of it as teachers. Sometimes we always like to buy a little bit more than what we actually need. What if we get a new student? What if one of them breaks? We'd have 24 extra than 4. So this is a great problem that you could utilize with students because really both answers are correct. I could suggest that the principal buy 780. I could suggest that the principal buy 800. I used my rounding techniques correctly to make an estimate, and I explained why that estimate makes sense to me. This one might be more cost effective. I wouldn't have as much waste. This one, however, I'd have 24 extra for new students who moved into Lawrenceville Elementary School. So great way to show your students more than one right answer, a great way to show authenticity when rounding. And remember, we want to make sure that we're utilizing strategies to help students to round, not just songs and different things to help students, because this helps students to understand the why. And remember, it might also help them to see that they're only 4 away from 780 or 24 away from 800, because they're not going to see that when they're using just generic rounding rules. So remember, anchor your rounding with those number lines, utilizing those benchmark numbers and midpoint numbers to help your students to be successful. Hey, third grade teachers. Let's take a look at this problem for AKS 2, IOA 2B. Now, you may notice that 2B, the actual wording of the IOA is a lot longer than IOA 2A, which is just to add and subtract fluently within 1,000. This IOA does tell us specifically, like using those part-whole strategies, properties of operations, place value understanding to solve those problems. It also says with this IOA to represent these problems using equations with a letter standing for the unknown, which we know are called variables, and then also to justify solutions using numerals, visual models, and or words. Okay, so we're going to try to do a lot of that here with this one problem. We're going to take a look at what this would look like concretely, then representationally, and then finally more abstractly, all with the same problem. Now remember, you will not use all of these strategies in one lesson. Okay. One thing that you will do with any problem that you work with when you're adding, subtracting is to, examine the problem. Let's figure out, what is this problem asking us to do? How do we know if it's an addition problem? How do we know if it's a subtraction problem? Because we're not always going to be told that. So we have to analyze, see what's happening, do a little movie in our mind, and then use some part-whole thinking to help us be able to really draw out a representation to figure out what is the equation that I need to use to solve. And then again, students can use the strategy that works best for them. So that's why we're going to show them this. We're going to put these out on our anchor charts in our classroom, and we can really build off of what was learned in Unit 1 with IOA 2A. Okay, so these are going to be a lot of the same strategies, but this time, because of the magnitude of our numbers, just like with what we've done in place value at the beginning of this unit, we are going to be using place value discs to add and subtract. So that is probably the biggest difference when it comes to the concrete part of this problem. So what we're going to do right now, we're going to pretend this is my anchor chart. I've got my problem written there. We're going to write out our part-whole thinking to figure out our equation, and then we're going to use our concrete manipulatives, and I'm trying the best I can to get that to fit all here under that ladybug, okay? So let's take a look at our problem, all right? At the beginning of the school year, the Gwinnett County Public Library began unpacking boxes of books to add to their collection. In August, they unpacked 1,265 books, and in September, they unpacked 2,573 books. So many books were unpacked in the first 2 months of the school year. Okay, so first of all, what is happening in this problem? Well, this problem seems to be about books at the library, okay? And they're unpacking boxes. So I'm literally visualizing unpacking boxes of books. And I know the value that they unpacked in August, right? That value is 1,265. And then I know the value in September is 2,573. So those values may help me to figure out, is this an adding or a subtracting problem? So let's look at our question. How many books were unpacked in the first 2 months of the school year? How many were unpacked? Well, let's think. If I take the amount in August and put that with the amount in September, I'd get a total amount. This sounds like addition, but let's draw a part-whole diagram just to see if my original thought works out. Because as a mathematician, I have an idea of what's happening, but I'm going to draw this model to really help me think through and verify is what I'm thinking correct. That whole show your work. So I can think that and say, let's draw this model. Let's see if what I think is going to be happening, if that makes sense in this model. So I'm going to show that this is the amount for August. This is the amount for September, okay? Because I know those two amounts, right? It just tells me the exact amount. So I'm going to write these in my table. Sorry, I have to keep looking to make sure I don't write the wrong number, because we all know that sometimes we might make a mistake when we accidentally write the number in our part-whole thinking model and we wrote it incorrectly from the problem. Very common mistake that we all make as humans, right? So I need to pay attention to that. So I know the amount in August, I know the amount in September. How many were unpacked the full 2 months of school? Well, I could get that by adding those two together, and I would figure out what the value is in this whole box, right? So this is going to tell me the total number of books that were unpacked. Unpacked. Okay. So I can use this part-whole thinking to help me now write an equation. All right, and this is where I'm going to utilize that letter standing for the unknown quantity. So I've got 1,265 from August. I'm going to add that to my 2,573 from September, and it's going to tell me my total number of books. So you know what? The letter I choose is B for books. Okay, that's what my unknown is standing for. We often have already used a question mark or a blank, things like that. But using that letter to stand for the unknown, they will see some of that in places. And it's a great way to incorporate that algebraic thinking, right? Because those variables show up in algebra later on. So it's helpful to make those connections for students. This letter just means we don't know what that total is. So another thing you could do, instead of writing this question mark here, you could just write a B. Either would be correct. Okay. So now I have my part-whole thinking and I have my equation. Now that I have that, okay, I'm going to push this off to the side, or I might have to push it up because I don't know if this is going to be enough room. I am going to use place value discs and a place value chart to help me add. Now, while I do that, I'm going to simultaneously show how that works with an expanded form model. That part's important, okay? Because we know that it's more effective for students to be using some of those more representational and abstract strategies. So we have to show how the concrete models work, okay? So let's draw my place value charts, okay? And let's see, I'm going to fold this to help me save some room. And I know my problem, I can always come back to my problem, but I want to make sure that we can still see that equation. Okay, so I'm going to see if it'll stay up here. Give me a little bit more room. Okay, that's about as good as it's going to get. Okay, so let's go ahead and create this place value chart, all right? Because I want to make it as large as I can to really show what's happening. Because remember, when I'm adding, and I'm using this place value chart, I need to make sure that I'm showing both add-ins. So this may or may not be enough room. So we've got my thousands, we've got my hundreds, got my tens and ones. Okay, so first thing I want to do when I am working with addition is I need to represent each number, right? So I'm going to represent that first add-in, 1,265. So again, I'm going to look at my number here, and I see that there's a 1 in the thousands place. Okay, so that represents 1,000. Okay. Next, I'm going to go to my hundreds place, and I've got 2 hundreds. I'm going to place my 2 hundreds there. Okay. Next, I have 6 tens. 1, 2, 3, 4, 5, 6. Okay. And then finally, I have 5 ones. All right. Making sure we can see everything. Actually, I might move this down a little bit. Make sure we can see it all. Oh, awesome. Okay, cool. Now, remember, that's just one of my add-ins here, right? Because remember, here was my problem. And remember, you'll have this up on an anchor chart as you're doing this simultaneously, possibly with those magnetic pieces. But now I need to represent this number, okay? Now, actually, what I would probably do here, so here's this add-in, right? Here's this add-in. Let's go ahead and show what is happening with this add-in using expanded form. Okay, I never have enough room. So we know that this place value is worth 1,000. Okay, so I have 1,000 for my first part of my number. Okay, and then I know I have 200. So remember, you're doing this simultaneously with chart paper. Now I can do it this way because now I can see it. Now I can show my 6 tens or my 60. And then finally I can show my 5 ones. All right, so what we'll do throughout this problem is as we build each part, I'm going to go back and show how it relates to the expanded form equation because that's going to help for our students too. All right, so now we've represented the first add-in. Now I need to go represent that second add-in. Okay, so you could do one of two things. If you wanted to draw a line to show the two, you can. That could be helpful in separating the two numbers. You can just leave a little bit of a space, whatever kind of makes sense for you. We might have done it multiple ways on some of our sample lesson plans. So let's just go ahead and build this. I have 2,000s for my second add-in. Okay, I could also just label the number on the side here. That's another way you could do this. So I have 2,000s, then I have 500s. Remember, I don't want to use the hundreds I already have. I have to show the 5 add-in or the 500s for this new number. Okay, then I have 7 tens for this next number. So 1, 2, 3. Oh, I only have 6 tens so far. So I only have 60. I need one more. There you go. You see that? Yeah, we can see that. Perfect. Okay. So I've got 70 or 7 tens. And then last but not least, I need my 3 ones. 1, 2, 3. Okay. So notice how I've just got like an invisible line right here. You can do that or you can draw a line, either or. I'm going to leave it off because I want to show what happens when I move it all together. Okay, so now with this expanded form equation, okay, I am going to show that next number, okay? So I've got my 2,000s, and you know what? I'm going to write it in a different color. That helps to show that it's a different add-in. Oh, you can't see that. I'm going to show that it's a different color. It's a different add-in, okay? And then I go to my hundreds, and remember we had 500s, which has a value of 500. We had 7 tens, so that has a value of 70. And finally, we have 3 ones. Oh, again. Okay, so there is my expanded form equation. Oh, no, I'm writing on a thing. Okay, so there is my expanded form equation of what I have just built on my place value chart. Okay, so if you're using magnetic ones up on the board and then writing this on chart paper, that is helpful. Okay, making sure we can see all of them. And I moved these pieces. All right, so now let's add. So when we are adding multi-digit numbers, we like to start in the smallest place value. What is that smallest place value? It is the ones place. Okay, so I'm going to lay this here. And we're going to work with that as we go because I want to focus on the ones, and we might have to look at some of the other place values as we go, right? So let's take the ones place. I have 5 ones and I need to add 3. Okay. So how many do I have now? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 ones. Okay. 8 ones. I'm going to go ahead and write that addition sign to set me up for the next part of my problem. Okay. Now, when I'm working with my tens, I have a lot of tens here. Wow, I have a lot of tens. If I'm adding them all together, okay, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 13 tens. Well, 13 tens has a value of 130. I could do that by counting by 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. Okay, so I could write 130 here. Another thing that I could do is show how I can bundle 10 tens to make 100. Okay, so let's do that. Let's bundle 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, here are my 10 tens, and I'm bundling those to make a 100. Okay, so these have the same value, these 10 tens or this 100. So I am bundling 10 tens. When I bundle my 10 tens, I need to now place that 100 in my hundreds place. Okay, so again, I had 10 tens plus 3 tens. I had a total of 13 tens or 130. I bundled 10 tens for 100 because I know those have the same amount. Okay, so now let's see on my expanded form equation, how am I going to show that 60 plus 70 what I just did? So let's look. I still have 30 in my in my tens place. But what did I do over here? I placed another 100 in my hundreds place, right? I placed another 100 there. So I need to add another 100 when I'm adding my 100. So I have the 200 and the 500 from my number, but that 100 represents that bundle of 10 from the tens place. So I'm going to leave the 30 there. Does that make sense? Thinking about expanded form, and place that 100 here in the hundreds place. Okay, I'm going to cover up this side for right now as we work here. So now when I'm working with my hundreds, I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 hundreds. Okay, so 8 hundreds has the value of 800. And that makes sense because 100 plus 200 is 300 plus 500 is 800. Okay, and last but not least, add up all my thousands, 1,000, 2,000, 3,000. I have 3,000 in my thousands place. Now this is that expanded form equation. So we know we need to add those place values back together. I can very clearly see I have a digit in each place value from my thousands all the way down to my ones. So when I put this back in standard form, I get a total of 3,838 books. So my value of my B is 3,838 books. So that is how I can solve adding using place value discs and matching that with the expanded form equation. All right, so now let's take a look at the same problem And let's look at what we could do to solve this problem without using our base 10 blocks. What if we would use just representational strategies here? Okay, so the same problem, but I've rewritten the equation for us. It's still here, this whole part whole thinking, right? I just want to give us a clean slate of what we're looking at here, okay? So same AKS, same problem, all right? All those same things. Let's just look at this more representationally, all right? So we'd already examined our problem. We'd already figured out what we have done, okay? And I am actually going to fold this because I can see what's underneath it, and that bothers me. Just being honest, right? Okay, here we go. So now, here was my problem, and here's the equation that I determined. I know it's addition, okay? So now, what happens if I want to just represent this with drawing base 10 blocks, okay? I'm going to do the exact same thing that we did with our actual not base 10 blocks, place value discs. I'm going to do the exact same thing, except we're going to be drawing them this time. I'm going to pair my place value discs with that expanded form equation, okay? So here we go. Let's draw our place value chart. Because when I am adding, I need to represent both of those numbers. Again, a great scaffold is to go ahead and have some place value charts if you need for kiddos, right? Make sure they can draw their own place value chart and then give them ones to use if you need to here and there, just for, time purposes. As they go through this strategy of drawing their representations. So again, I'm going to look at each value of my digits for each number, and I'm going to draw each of them in my place value chart. And at the same time, I am going to be drawing my expanded form equation to match what is happening. Okay, I'm going to still put this up even a little bit further just to make sure we have plenty of room. Okay. All right, here we go. So okay. So let's represent our number. I have 1,000. I'm going to go ahead and write the value in. So remember, that's that one extra step that we haven't had to do with base 10 blocks. We have to write the value. Okay, so I have 1,000 in this number, or this add-in. I have 200s. I have 6 10s. 1, 2, 3, 4, 5, 6. And then I have 5 1s. Be completely honest, I have been afraid that I was going to accidentally represent this number while trying to represent this number. So I'm trying to make sure everything matches, right? So I just want to double check. 1,000, 200s, 6 10s, 5 1s. I'm good to go. All right. So that's one thing to help model for your students, just to help to make sure we don't make that mistake of accidentally representing the wrong number. Okay. All right. So now I'm going to represent my next add-in. And when you're drawing a representation, especially early on, like when you model for your students, you can easily use, if you're on your chart paper, which would be great, you can use 2 different color markers. I'm going to use 2 different color pens. It's just a great visual model to help those students to see the 2 separate add-ins. So now I want to represent 2,573. So I have my 2,000. Okay. I have 500s. 1, 2, 3, 4, 5. Okay. I have 7 10s. 1, 2, 3, 4, 5, 6, 7. And I then have 3 1s. Okay, so I've represented them using the drawing of my place value discs. Now, what I should have done is written my expanded form at the same time for each add-in. So let's take a look at that, right? So I need to write out the expanded form just like we did with our actual place value discs. So I'm going to go back to that color because I like to keep that the same also. Okay, so I have my 1,000 plus 200 plus 60 plus 5. Okay. And then I show my next add-in because I'm adding these. I have 2,000. I have 500s. I'm looking at this to double check, and I'm also double checking with the digit. I have 7 tens for 70, and then I have 3 ones. Again, this part will look exactly the same. We just want to show what happens when we draw here because it is a little bit different. I can't actually erase. I don't want to erase. That might mess up something else with my problem as students are working. Okay. So just like we did with our place value discs, we are going to start adding in the ones place. Okay. So look at my ones place. I'm adding 5 plus 3. So I have 5 plus 3. I can count all, and I know that I have 8. Okay. Next, I get to the tens place. I notice I have a lot of tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. So 60 plus 70 is 130. I could write that here. But one great thing to show students is how you can bundle 10 tens to make a 100. This is what we would consider regrouping with addition, okay? So to do that, I know that 10 tens has the value of 100. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's circle these. Okay. And these are now, I'm bundling those for another 100. Okay. So I no longer have these 10 tens. I only have these 3 tens or 30. And I'm going to add now this extra 100 over here in my hundreds place. Okay, so just like I drew my 100 here, because those 10 tens have now been regrouped to 100. Okay, just remember it's a different way to represent this number. Okay, it is now, I have an extra 100 in that hundreds place. So now when I add, I have to make sure I add that in. So 200 plus 500 plus 100 gives me a total of 800. And then 1,000 plus 2,000, I can see that very clearly, is 3,000. Now, one thing also to remember is that as students begin with this piece, I don't need to be regrouping in every place value every time. That could be very overwhelming for students. So I might want to start out just showing how I regroup with 1 place value. Then I can show what happens when I need to regroup with 2 place values. And then, oh my goodness, what happens when I'm regrouping in 3 of the place values. Okay, so that scaffold should be in place there for your students. So also think about that when you're selecting tasks for students and selecting the different problems. You know, are you only including 1 place value to regroup? Because if you are, we probably want to show how you might be regrouping in 2 place values. Or are all of my problems regrouping too many times? Because that's going to really set those students up for possibly making a mistake just with all the different regrouping that is happening. Okay, so just make sure you're paying attention to those different numbers. Okay, now, same problem, but let's show 2 more strategies. Okay, I am going to take this problem out to make sure we have lots and lots of room down here, but I'm going to keep this representation. And you know what? I'm just going to keep this one out to the side right here. Why not? That way you can still see that. We can see the AKS and part of the IOA. Perfect. Okay, let's take a look at partial sums. All right, we looked at partial sums when we worked with our 3-digit plus 3-digit numbers back in Unit 1. We're going to use that strategy here again. All right, so when I use partial sums, I do set up my problem. Let me draw kind of a little. You might do that on your anchor charts too. All right, so with these partial sums, I am going to stack those numbers based on place value. this will begin to look like the algorithm, which this is one of the next steps towards the algorithm. So when you think of it this way, I might want to pair my expanded form with my partial sums. We're going to see how that relates. And then we can see how the partial sums then helps with the algorithm. We're going to do each of those today. All right, so we're going to do the same thing we did here with our expanded form. I'm going to start in the ones place when I use partial sums. All right, so I want to add 5 plus 3. All right, I know 5 plus 3 is 8. Again, I should have the same value here, right? Okay, so it's a great way to even help check students to make sure they're on the right track. Next, I'm going to add my tens. So remember, even though how these problems are written, this isn't just 6 plus 7. This is 6 tens, or 60 plus 70, or 7 tenths. All right, so I might notice here that 60 plus 70, this is, I could almost set up as like a doubles problem, because if I decompose 70 into 60 and 10, I know 60 plus 60 is 120, plus another 10 is 130. So just what's really important to write here, I have to make sure that those place values, right, all are in the correct pieces. What I could do is I could have written 30, and then I could have written 100 if I wanted to. Or in that case, I could have written 120 plus 10. Either way would be correct. I'm just adding in parts here, okay? Next, I want to add my hundreds place. Remember, this isn't just 2 plus 5. This is 200 plus 500, okay? So that means I'm adding 700. All right, and then one more step here that we didn't have in Unit 1. I'm adding the thousands place. 1,000 plus 2,000 gives me 3,000. All right, now I also want to make sure, notice how, and if you use notebook paper, it could help make sure your place values are all lined up. That organizational piece is really important as you start to use partial sums and the algorithm. So remember that with your students, to help, just remind them to be neat and take your time. All right, so now I'm going to add all my ones, add all my tens, add all my hundreds, and finally my thousands. And notice I do have, oh, I didn't write that final answer over here. I apologize. My answers are the same, okay? Like we had before over here, okay? Still 3,838 books. Now, last but not least, teachers, it is okay to use the standard algorithm for addition when adding multi-digit numbers. That is going to be something different for us, but we want to remember the steps we've taken to get there, right? Do students have to use all these strategies every single time? No, we should not be using the same strategy to solve the same problem on the same day like I am in this video, because you see this part does take time. But when I use the standard algorithm, I want you to remember, or at least this is one thing I like to do, I don't write the commas, and I probably shouldn't have written the commas here either. But the commas sometimes, if I write them with my problem, sorry, I'm talking and writing numbers, and I'm double checking to make sure I've written the correct problem here. So I just need to make sure, yes. Okay. When you're working with the algorithm, I still talk place value, just like I did through partial sums. I like partial sums because it enforces the place value of what each digit represent. That's why expanded form should be paired with partial sums, and why partial sums should help bridge the gap to that standard algorithm. Okay, so I'm going to still start in the ones place, that smallest place value, and work my way to the largest place value. And I'm still going to be talking about each place value, right? So 5 ones and 3 ones is 8 ones. 6 tens plus 7 tens. Okay, this gives me 13 tens. But remember, I can't write 13 in this one place value because I only can have one digit in each place value. Okay, so what do I do when I have 13? Well, remember, 13 tens really means I have 3 tens and 100. So I have 3 tens and 100. Again, See how that relates. So if you show these pieces, it's okay to show students over the course of a couple days how it has grown and how they do relate. So when you look at your anchor chart, you might want to consider using a similar problem, okay? Or at least a problem that has similar numbers, right? So now I'm in my hundreds place. I have 100 plus 200 plus 500, which gives me 800s, which makes sense. I'm in the hundreds place. And then finally 1,000 plus 2,000 is 3,000. So 3,838 books. So how many books were unpacked in the first 2 months of the school year at the Gwinnett County Library? There were 3,838 books unpacked. Oh, there I did it again. Okay. 3,838 books. Remember, teachers, we want to expose these strategies to students because we want students to be able to select which strategy is most efficient for them. We definitely want to start with those concrete experiences here as students are adding multi-digit numbers for the first time. And we also want to make sure that we are providing those scaffolds for students. We don't want to start with the standard algorithm for addition. Remember, the word algorithm just means a step-by-step process. Really, we're doing a step-by-step process here too with the expanded form equation. It's just historically, we just call this using the algorithm, or that might be how parents might see it too, okay? So just remember, when we solve using a standard algorithm, we still anchor it in what we have learned with place value to help students understand that this one is not just a one, this one is 100. Okay, and that's the value of that digit. So make sure you're using that vocabulary with your students, using your place value charts, your manipulatives, and please make sure you have anchor charts in your classroom to support your students' understanding. Hey there, third grade teachers. Let's take a look at this problem for AKS 2, IOA 2B. This IOA, again, deals with adding and subtracting within 10,000. So we're going to use this problem to help us look at some subtraction strategies for multi-digit numbers. Now remember, we don't want to tell students every time when we begin with a problem that, hey, this is a subtraction problem, because then students will start not to read and think through the problem. So we have to model each problem as if we don't know how we're going to solve it today. We need to play that movie in our mind and get an idea of what strategy we are going to, well, not what strategy, actually what operation we're going to use, so we can then decide on our strategy to solve. Okay, so we're going to talk through this problem. I'm going to start with our concrete strategy of using place value discs with subtraction, just like we did with addition. And then we'll move on to our representational and abstract strategies, okay? So I'm going to start with analyzing this problem, and then we will go through all of our strategies, okay? Okay, at the start of the football game, 3,546 people were in the stadium. At halftime, 928 people left the game. How many people stayed at the game after halftime? So let's take a look at our problem. We know that this problem is about a football game, and there could be lots of different things about a football game, but in this case, it's about the people in the stadium, and I know the total amount of people, okay? The other part that I know is I know that this many people left the game. So let's think about that. I'm imagining a football stadium, right? And imagining it filled with people. If 928 people left the game, that means they leave. They leave the stadium, they go home, they're no longer going to be at that game. So there's going to be less people at that game than there were at the start. So my question that I'm trying to find, how many people stayed at the game after halftime? Well, let's think. That's my total, and some people leave. Kind of sounds like I might be subtracting, right? So let's take a look at a part-whole diagram to see if that holds up here. Because this part-whole diagram, this organizer is really going to help my thinking. Now, in this case, let's think about what I know, and I know this total amount this time, okay? Which I don't always start by knowing that total amount, right? So I'm going to actually put that total amount in this top box. This is the total amount of people. Sometimes I write the amount in the box. Sometimes I write it like on top of the box. That's completely up to you and how much room you have. I don't like to stuff things in a box because I like for students to see the numbers. Okay, so I see this is my total, right? That's the total number of people at the stadium. And then I know some leave, right? Technically, half don't leave. So technically, this is a smaller box, right? I know some people leave. 928 people leave the game. Okay, they leave the game. So now I need to know the remaining number of how many people stayed at the game. Okay, so I have my total number of people, I have the amount that left, and I have the unknown amount, which would be the number of people that stayed. So I know the whole and I know a part. That means I can use subtraction. So what I thought was happening in the game was subtracting. When I set up my part-whole diagram, it confirmed that I can use subtraction to solve this problem. Now remember, teachers, that I could use think addition to solve subtraction. That strategy you will find in your Analyzing the Standards document, okay? So I am going to write my subtraction equation, 3,546 minus 928. Okay, now I don't know how many people stayed at the game. That's what I don't know. So in this case, I'm going to use a letter to represent my unknown. I'm going to use the letter G. What does G have to do with? It's how many people will still at the game. I could have used the letter P. I could have used the letter H because it's after halftime. I usually pick a letter that goes along with the problem. That's totally up to you. Okay. So here we have our equation that we're going to use to solve. All right. So now I want to use place value discs to help me solve this problem. All right, because that's our concrete model of how we start with subtraction, because we really want to show students what is happening here. Now, I'm also going to be recording the expanded form equation, because again, we're relating back to what we already know, because our goal is to move students away from the concrete manipulatives. That is the goal here, right? Because we know it's more efficient to do so. Some students are just going to need to work with this place value disc a little bit longer, and that's okay too. All right. So I'm actually, just to help me as I build my numbers up here, and so I can help not forget what problem it is I'm solving, I'm going to write my equation up here, up above my place value chart. So I have 3,546, and I am subtracting 928. And that's going to equal how many people are left at the game. So it's always helpful to have your equation there. Remember that when you're modeling this for students, you want to make sure that you have, if you're using the document camera here, like I am, that you still have a way to record that expanded form equation. If you have the magnetic forms of these, you can do that part on the board and then show the expanded form equation on an anchor chart, because remember, we want to provide that anchor chart as ways for students to be able to refer back to that strategy, just to help to give them those friendly reminders. Okay, so here's our problem. And I am going to be subtracting today. Now, like I said, we will use our expanded form equation as we go. So I'm going to need 1,000 tens and ones. Get some of those out here, and let's build our number. Now, one thing we need to remember when we are subtracting is that unlike addition, where we built both add-ins, I'm going to first build this number, and then I'm going to subtract or take that amount away. Now, remember, not all subtraction problems are just takeaway or removal. Okay, that's why we have those different problem types in the pacing guide, and that it is important that students know that it's not just always a removal or a subtraction, but I can always think about subtraction in this way. In this case, there are 928 people who leave the game. So this is an example of that. But I could be comparing two amounts and I need to find the difference. So just remember that it's not always just take away or subtracting, right? Okay, so let's first build this number. I have 3,000s. Okay. I have 500s. Okay. I have 4 10s. And then finally, I have 6 1s. Okay. So let's just make sure. I'm going to go ahead and we're going to write out the expanded form equation based on what we've built right here, just to make sure that we have built the correct thing. Okay. So let's use our expanded form equation here. All right. So let's see. 3,000. Okay, remember, even though this is subtraction, I'm writing out the expanded form of the numbers. I do use those addition symbols. I have 500s. I have 4 10s. And again, I'm verifying that I have built my number correctly with my equation also. And then finally, 6 1s. Okay, now I'm going to be subtracting 928. Okay, so instead of building 928, I'm going to be removing 928. So I'm just going to go ahead and show that expanded form because I am going to take away in parts, right? I'm going to take away 8 1s, and then I'm going to take away 20 10s, and then I'm going to take away 900s. So there's my expanded form equation that's going to match what I'm doing, okay? Now, again, there's a whole lot of addition symbols here, but I need to remember that I'm subtracting, okay? So we're going to keep up with this as we go through our problem, all right? So let's first start in the ones place, all right? I have 6 1s. That's what I have here. I am subtracting 8 1s, okay? When I look in the ones place, there are only 6 1s for me to take away. Okay. So I cannot subtract the way the number is represented currently. Okay. I can subtract 6 minus 8. We don't want to say you can't subtract 6 minus 8 because the reality of that is that statement does not hold up well when students get to middle school and start learning about integers and negative numbers, because 6 minus 8 does give you a negative number. So we don't want to say that you can't we can't subtract 6 minus 8. But the way my number is listed now, I am unable to physically remove 8 1s. Okay, so I can't do it yet, right? So I have to do something else. I have to do a little bit of regrouping here in order to help me subtract, because I know I can represent my number in multiple ways, right? So I'm going to go over here to this tens place, and I know that 10 1s is the same as 1 10. Okay, so let me say that again. I know that 10 1s is the same as it's the same as 1 10. I can exchange them, right? I'm going to regroup this. Why am I going to regroup it? Why did I go here? Well, I need 1s in my place value chart, and I can't just randomly put 1s here. I need to exchange what I already have. So I'm going to represent this 1 10 a different way. So I'm going to exchange it for, and there's my 6. So I want to make sure that I use the correct amount, right? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I need one more. 10. Okay, that's not all on the paper. We're going to move it all up there. Oh my goodness, look at all those ones we have now. Now we have plenty of 1s to subtract. Plenty. Okay, so before I do any other subtraction, let's mark what we just did here. Okay, I'm going to actually lay this right here so we can really look. Remember, I started off with 40 or 4 10s and only 6 1s. But I have done some regrouping here. That's no longer what I have. So now I have to indicate what I currently have, right? So this 40 is no longer a 40. It's now a 30 or 3 10s. The 6 is no longer just 6 1s. I now have 16 ones. And I can count to prove that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So what I just showed with that regrouping of a 10 to 10 ones, okay, I didn't remove that number. I didn't borrow the number. It didn't just, disappear and never come back. So I am regrouping it because I need it this way in order to help me to subtract. I can now subtract what I need to, okay, and get a positive whole number, right? So when I look at 16 minus 8, hopefully students remember that this is one of those, double facts in reverse. So 16 minus 8, I could take away 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm left with 8. Okay. 16 minus 8 is 8. Awesome. Okay, I've subtracted in the ones place because I'm starting in that smallest place value. Now let's go to the tens. I have 3 10s or 30. I used to have 40, but now I only have 30. So I have to look at that number and I need to subtract 20. 10, 20. I am left with 10. Fabulous. Okay, moving right along. Okay, now I'm going to subtract in my hundreds column. I have 5 hundreds. I need to subtract 900. Okay. Right now I could only subtract 500, but I need to subtract 400 more. Where does that 400 come from? Well, remember, it's here right now. I just have to regroup it in a way that I can actually use it. I have to represent the number in a different way. So friends, 1,000 is the same as how many hundreds? 10. All right, so that 1,000 is now going to become, we're going to have a lot. Let me move these together because I don't. There was the 5 I started with, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's push those all together. Okay. Here we have it. I exchanged my 1,000 for 10 hundreds. Because remember, I only used to have 5. And now, if I've placed 10 hundreds in here, now I should have 15, right? So that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. I have 15 hundreds. Well, if I count by 100s, I'd have 1,500. So on our expanded form, before we go any farther, let's show what we just did. My 3,000, I now only have 2,000, right? Because I exchanged this 1,000 for what? 10 10s. This 1,000 now goes with that 500. So that's why this 500 is now 1,500, okay? Or another way that we can say that is 1,500s, okay? And that's why a lot of times you hear adults say 1,500, not 1,500, okay? So now that I have my 1,500, I can subtract my 900. 1, 2, 3, 4, 5, 6, 7, 8, 900. So I did count single digits, but I was counting hundreds. I count 100, 200, 300, 400, 500, 600, 700, 800, 900. I subtracted my 900s. So I am left and finally my thousands place. There is no digit in the thousands place. So there is nothing for me to subtract. So my answer is going to still have 2,000. So how many people stayed at the game at halftime? I'm going to take my expanded form equation and write it as base 10 numerals or standard form, but put those pieces all back together. 2,618 people stayed at the game after halftime. So remember, when we are using concrete manipulatives, I want to continue to show the expanded form equation to help students understand why we regroup from another place value, that it's not like it completely goes away. We're just representing the number differently to help us to be able to subtract in that place value. So, which strategy? In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. This is from the Georgia DOE's Comprehensive Grade Level Overview. Thanks again. We appreciate you watching.